Alright, so we're going to go over the rest of the examples for measurement and units and scientific notation in the book. We're going to start with example 1-3, which says an 8,000 meter peak. The 14 tallest peaks in the world are referred to as the 8,000ers, meaning that their summits are over 8,000 meters above sea level. What is the elevation in feet of an elevation of 8,000 meters? So here we just need to use what we know about the conversion between feet and inches and centimeters and meters to come up with a conversion factor that we can use to turn meters into feet. And there's two ways to do this. And I'm going to do it the way that I am most comfortable doing it. And then I'm going to show you another way, finding one conversion factor, which is a useful way to do it if you are going to be frequently applying the same concept. So we're going to take, so this is example 1-3, and we're going to take an 8,000 meter peak, and we're going to convert it into feet. So one thing that I know is I know the conversion between meters and centimeters. So in 1 meter there's actually 100 centimeters. So that gives me the value in centimeters. And then from there I know the conversion between centimeters and inches. And that's going to get rid of centimeters and give me inches. And then I know the difference between inches and feet. And so that's going to give me my answer in feet. So my equation becomes 8,000 times 100 divided by 2.54 divided by 12. And so that's going to be 26247. And it's important if we're looking at exactly 8,000 meters, 1, 2, 3, 4 significant figures, 1, 2, 3, 4, so it's 26250 feet using correct significant figures. Now, this way works great if you're doing a standalone problem. But let's say you are going to need to apply a conversion factor between meters and feet multiple times. In this case, it might be useful to come up with one conversion factor, one equivalency that you could apply, just one and done. And so we're going to do that. In the book, it shows you first how to turn a foot into a meter. So we're going to turn a foot into a meter, and we're going to turn a meter into a foot. Alright, so 1 foot, when we think about it, I can turn 1 foot into 12 inches. And I can turn 1 inch into 2.54 centimeters. And I can turn 100 centimeters into 1 meter. Alright, and if I do this, right, foot's going to cancel with foot, inch is going to cancel with inch, centimeter is going to cancel with centimeter, and the final answer, the final number, will be what 1 foot equals in meters. So that means that I'm going to take 12 times 2.54 divided by 100, and I get this value of 0.3048. And that's meters per foot. Right? That's how many meters are in 1 foot. Likewise, I can turn a meter into a foot, and that's just a matter of doing the inverse of this. So that means that I'm going to inverse this. And if I inverse this, if I make it, instead of 3.048 meters per foot, I make it foot per meters, I'm going to get 3.28084 feet per meter. And now I can apply this to problems like it back and forth as I need. So it asks us then to take that 8,000 and let's compare it to our original answer, 8,000 meters, and I'm going to multiply that by 3.28084 feet per meter, and I'm going to get the same answer, 26247 feet, which is 26250 feet in correct significant figures. So you can use this strategy, either one, as needed to solve a problem like this. In exercise D, it says there are only 14 8,000 meter peaks in the world. It gives you these peaks in table 1-6, and it asks you to calculate the elevation of the world's 3 highest peaks. And so I've done that for you. Here in exercise D, you can see the top 3 highest peaks. Here's 1, here's 2, here's 3, and because I'm a go-getter, there's number 4 right there. So you can see that I actually, because of that repeatability of using the same conversion factor, I used the conversion factor I derived in example 1-3 to quickly convert all of the peaks into feet. And so that's really useful. Moving on to example 1-4. Area of a semiconductor chip. A silicon chip has an area of 1.25 square inches, and we're going to express this in squared centimeters. And so this is a really nice thing because we already know the conversion factor. It's actually been showing up quite a bit. And the 1 inch equals 2.54 centimeters. But you see, we have 1.25 inches squared. That's squared inches. So that means that we're going to have to cancel inches twice, right? It means that 1 inch equals 2.54 centimeters. If I just use this, I'm only canceling out one of these inches. So that means that this is going to be squared, which means that I'm writing basically 1.25 inches squared, and I'm going to be doing 2.54 centimeters over 1 inch. There's 2.54 centimeters over 1 inch. So it takes both of these inches to cancel out both of these inches. So that means that I'm basically multiplying 1.25 by 2.54 squared. So I do that and I get 8.06 centimeters squared. Alright, so be very careful anytime you have square value or cubed value that you apply the conversion factor the correct number of times. And that one was, again, example 1-4. In example 1-5, right, we're going to be taking a look at speed. Right? We've got a posted speed limit of 55 miles per hour, and we want to know what the speed is in meters per second and in kilometers per hour. So we have 55 in example 1-5. We have a speed limit of 55 miles per hour. And first we're going to convert miles per hour into meters per second. Alright, so we're going to turn this into meters per second. And then afterward we're going to turn it into kilometers per hour. So we're going to use our conversion factor, 1 inch equals 2.54 centimeters. And we're actually going to recall that there's 5,280 feet in a mile and 12 inches in a foot. And also 1 hour contains 60 minutes per hour and 60 seconds per minute. So that means that our conversion factor between seconds and hours is 3,600 seconds per hour. That's a really convenient one to keep in mind. 60 times 60 is 3,600. So we're going to change it. We're going to convert 1 mile into a meter. All right, so 1 mile. And we're going to use our conversion factor. Here it says that in 1 mile there's 5,280 feet. and then in 1 mile there, in 1 foot there's 12 inches, and in 1 inch there's 2.54 centimeters, and in 1 meter there's 100 centimeters. So this is going to give us our conversion factor between a mile and a meter, which is pretty darn nice to have, because once we have it, we can apply it. So feet cancel with feet, mile cancel with mile, inches cancel with inches, centimeters cancel with centimeters, and our calculation becomes 1 times 5280 times 12 times 2.54 divided by 100. So it turns out, and I actually knew this already, there's 1609 meters per mile, and it's 16.09 or 1609.33. That gives us that value. So that's how we're going to convert between meters and a mile. If you've ever run the 1600 in track, then you probably knew that that was pretty darn close to a mile. But that gives us our 1609 meters per mile. And since we know that each hour contains 3,600 seconds, we can go ahead and we can do this conversion. 55 miles per hour. And we're going to say that there's 1,609 meters per mile, and in 1 hour we have 3,600 seconds. So miles will cancel with miles, hours will cancel with hours. It doesn't matter if they're lined directly up. This is multiplication, so according to our order of operation, all multiplication can be done simultaneously. So it's going to be 55 times 1609 divided by 3,600, and that's going to give us 25 meters per second. And in the second part, we're going to go ahead and we're going to take a look at converting that into kilometers per hour. So meters to kilometers, 25 meters per second. We're going to change meters to kilometers. We know that there's 1,000 meters in 1 kilometer. So that's going to give us, and then we also know that there are 3,600 seconds in 1 hour. So when we do this calculation, remember, it doesn't matter in multiplication.
Mariana Ziegler to the front office, please. Mariana Ziegler to the front office, please.
Alright, so that means that when we do this calculation, it's going to be 25 divided by 1,000 times 3,600, and that's going to give us the value of 88.
Hector Alcantar, front office, please. Hector Alcantar, front office, please.
And obviously you know that I'm sitting here right at school trying to get these done for you. So it's always nice to kind of have this system under your belt to work on. We're going to go ahead and I'm going to encourage you to look at 1/6 through 1/9. But I'm not going to be doing these in a specific recording video because I'm actually going to be having you do a couple of similar problems to this in the classroom. Not exact, but go ahead and take a look at them because you're going to be doing similar exercises for 1/6 through 1/9 because they're really useful for you to have. So that's it. That's all of the information from Chapter 1. I want to make sure that you're comfortable and familiar with it. And we're going to pick up with doing a little bit of this work in class.